Okay, today we are finding all parts of a right triangle now that we know how to find the sides using SOHCAHTOA or an angle using SOHCAHTOA. So if you think about it, all right triangles have one 90-degree angle, two acute angles, the other two angles must be acute, one hypotenuse, and two legs. So these are all the parts. If I add them up, I have 2, 3, 4, 5, 6. So solving a right triangle means find measures of all sides and all angles. Since a triangle is made up of angles and sides, it has 3 sides and 3 angles, so there's a total of 6 parts that need to be accounted for. There's a couple different things that we have to have in order to use trig. We either have 2 sides of the triangle, of the right triangle, or one side and one acute angle. So that means in this case we would have one side length and one acute angle and one right triangle, or 2 side lengths with the one right angle. Angle is what I meant. So little reminder here. If you're finding a side, you're going to use sine, cosine, or tangent. Those are the regular buttons on your calculator. And if you're finding an angle, you're going to use the inverse key. So you have to hit second sine in order to get to the sine with the -1. That means angle. Cosine, second cosine to get cosine to the -1. And second tan to get tangent to the -1. That means you're telling your calculator, I need an angle this time. Okay, so let's look at these examples here. Oops, went too far there. Just trying to make it a little bit bigger. Okay, so let's solve the right triangles. So here, angle A, I don't have, but in order to find angle A, from this place, if I'm standing here, I'm thinking, okay, 3 is the opposite, 2 is the adjacent, C is the hypotenuse. So since I have opposite and adjacent to find this angle, I can use tangent, the inverse of tangent, or tan to the -1, and tell my calculator opposite over adjacent, which is 3 divided by 2. Okay, when I put second tan, 3 divided by 2, close the parentheses, hit the enter button, I should get, let's see, I haven't done it yet, so I'll get my calculator ready. Second tan, 3 divided by 2, close the parentheses, I get 56.3099. I'm going to round to the nearest tenth, so angle A, I will say, is 56.3 degrees. Now going over here to angle B, now I'm standing in a different place on my triangle. My opposite side is 2, my adjacent side is 3. So opposite over adjacent this time, my tangent is going to be 2 over 3. So in my calculator, make sure you clear it, second tan, 2 divided by 3, and close your parentheses, and you should get 33.69, so I'll say 33.7 degrees. Notice when I add these two numbers together, I do get 90 degrees. Angle C, of course, is our 90-degree angle. That one we already know. Okay, side AB, let's see, that's our hypotenuse, don't have. BC, I have 3. And CA or AC, I have 2. So let's practice. We have 2 sides of a right triangle. How do we find the third? Well, since this is the hypotenuse, I can set up my equation. 3 squared plus 2 squared equals C squared, my hypotenuse squared. 3 times 3 is 9. 2 times 2 is 4. Add those together and we'll get 13. Now 13 is C squared and I want C. So I need to take the square root of both sides, and since I'm going to keep it in exact form when possible, and there's no way to simplify the square root of 13, side C, or AB, is the square root of 13. Now moving over to problem B. Let's see, angle J, I'm going to put in the things that I already know. Angle J is 90 degrees. Let's see, angle H is 25 degrees. HJ is 9. And HG is 13. I have the hypotenuse this time. So really, I'm missing G and JG. Now, angle G can be found just by subtraction. I already have 25. I know this one is 90. Add those two together, we get 115. So if I add them together and get 115, and I know my total is 180, all I'm doing is subtracting to find out what's left over. And I find out, hey, it's 65 degrees. Because 65 plus 25 must equal 90. Now to find my missing side, since I happen to already have two sides on this one, I'm going to use my Pythagorean theorem. 9 squared plus h squared, that JG, equals 13 squared, my hypotenuse squared. 9 times 9 plus the h squared equals 13 times 13. Subtract the 81 from both sides, and I find out h squared is going to give me 88. So that means the square root of h squared, which is h, gives me the square root of 88. 88 is 4 times 22. 4 is a perfect square, so I can take the square root of 4 out, and the 22 stays under the radical. 2 root 22. Okay, let's look at problem C. For some reason, we don't have everything written down here, so we'll write it in. The measure of angle R, the measure of angle S, the measure of angle T. And then we're looking for the three sides, RS, ST, and RT. Now, as you noticed in the first two problems, we already had two sides of the triangle, of the right triangle. In these two problems, we only have one side and one angle. In this problem, not this one, we have two sides over here. Okay, so our angle R is 57 degrees, so we'll fill that in. And our angle S, we already know, is 90 degrees. Let's see, what would angle T be? What is 90 minus 57? Yep, I think it is 33 degrees. So if I add 33 plus 90 plus 57, I should get 180. Okay, let's see. The side we do have is ST. That's 15. Now we're going to have to use our trig functions. We can't use Pythagorean theorem here because we only have one side of our right triangle. Thank goodness we have one of the acute angles. So to find RS compared to the angle that we have, and we always want to use the angle that's given to us, not this one that we found. So from the 57 degree angle, I have the opposite, I want the adjacent, and I want the hypotenuse. So I'm just labeling those. Okay, opposite and adjacent is tangent. So the tangent of 57 equals the opposite over the adjacent. Variables on the bottom, so this is a division problem. Don't forget that. Okay, so we want to start with the 15 divided by the tangent of 57, close it up, and we find out that side A, which is RS, equals 9 point, and we'll round it to the 10th, 7. So 9.7 here. Remember, you must do division when the variable's on the bottom. Down, divide, top, times. Okay, let's find the hypotenuse this time. Standing on our angle 57, we have the opposite. We want the hypotenuse. OH. That's right, that's so. So we're going to use the sine of 57 equals opposite over hypotenuse, which is RT. Variables on the bottom, so it's a division problem. So if you want to write it out, 15 divided by the sine of 57 is what we're doing. 15 divided by the sine of 57, close up those parentheses, and I get 17.885, so this is going to round to 17.9 when we round to the tenths. Good job, we found all the missing parts, the other acute angle and the two missing sides. Now let's move on to problem D. Let's see, we need to find, I'll do that one in purple. We've got the measure of angle G we need. We need the measure of angle H, that will be easy. And the measure, oops, didn't mean to do that. Let me get my trusty eraser out. H, and let's see, we need the measure of J. For sides, we've got GH. We'll fill that in. We need HJ, and we've got GJ. That's just showing all the 6 parts. Okay, so let's see. We've got GJ. That is, it looks like 16. I'm going to check my paper too. Yeah, I think that's a 16. And then GH is 14. This one is 14. And we know angle H is 90, so we're going to fill in what we do know. We've already got that one. So I can easily find my third side by using Pythagorean theorem. Since I have 2 legs, I have one leg, I want the other leg, and I have the hypotenuse, I can use a squared plus b squared equals c squared. And 14 squared is 196 plus b squared equals 16 times 16 is 256. So when I subtract the 196 from both sides, let's see, I think I have 60 left over. Yep, that should be right. So b is the square root of 60, and 4 goes into 60 15 times. So b equals, square root of 4 comes out, and that's 2. 15 stays in jail. So our missing side, HJ, is 2 root 15. Okay, let's find our 2 missing angles. Angle J. Opposite from angle J, if we're standing on angle J, 14 is opposite. This 16 is hypotenuse. Opposite hypotenuse is sine, and we're looking for an angle, so that's second sine, and we feed it opposite over hypotenuse. And let's see what we get. Second key, sine, 14 divided by 16. Close up your parentheses, and we get 51 or 61.04. So we're going to call this 61 degrees. Let's go over here to angle G. Now we're standing over here on angle G. Now 14 is an adjacent side, and 16 is still the hypotenuse. So adjacent and hypotenuse, that's AH. So this would be the cosine of -1, and we're going to take that 14 divided by 16, adjacent over hypotenuse, and find out what we get. It's a good way to check it. 14 divided by 16. If we just subtracted, we wouldn't be checking our answer. So 28.955 will round to 29 degrees. Amazingly, even when we round our answers, they add up to 90. Okay, once you find one angle, like the 61, don't automatically subtract from 90 to get the 29, because if you made a mistake on angle J, for example, you will also make a mistake on angle G. But if you do them using your inverse functions, then you can check your answers when you're done, which is a much better way of doing it. Okay, let's turn to page 19. Okay, at the first one on page 19, it says round all answers to the nearest tenth. Okay, so we're going to do that. But over here, we have plenty of space on the side or above where it says name. Make sure you write out SOHCAHTOA and anything else that's going to help you remember how to work these problems. You can see how sick I am today. I'll be there tomorrow, but I've just got to stay home another day today. The S in SO is for our sine function. The C is for the cosine. And the T is for tangent. And remember, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, let's move over here. I'm changing to my favorite purple. Let's see. We've got AC. We've already got that. That's 4. We've got angle B. We've got angle C. Okay, so for angle A, we can subtract 90 minus 35 because the two acute angles, again, have to add up to 90. And we get 55. So angle A is 55 degrees. Okay, that's for angle A. That's what I did first. Angle B plus angle A are two acute angles that must be complementary. They must add to 90 because we already have 90 here. All we have left over is 90. Now let's look at side AB. We have an angle and we have a side. We're looking for the hypotenuse. So from the 35-degree angle, we have the opposite. We want the hypotenuse. So the sine, opposite over hypotenuse is sine. The sine of 35 equals the opposite over the hypotenuse. Variables on the bottom, so it's a division problem. 4 divided by, that's the number 4 there, the sine of 35 is what goes in your calculator. This will go like that. Close it up. So 4 divided by the sine of 35. Oops, got to turn my calculator on. 4 divided by the sine of 35. 6.97. So we're going to round to the nearest tenth. I'm going to have to say it's 7. So the hypotenuse, AB, must be equal to 7 when I round it to the nearest tenth. Now, lastly, I have to find side BC. From the 35-degree angle, which is what I want to use, the one that's given to me, I'm looking for adjacent. I have the opposite. I have opposite looking for A. OA. That's right, that's TOA, OA. So the tangent of 35 equals the opposite goes on top, the adjacent on the bottom, which I don't have. Look at it, the variable's on the bottom, so it's a division problem. 4 divided by the tangent of 35 is what we're putting in our calculators. And again, don't forget to close your parentheses. 4 divided by the tangent of 35, 2.8 when I round to the tenths, because I have 2.8008. So rounding to the tenths is just 2.8. Okay, everything's accounted for. We've got angles. We've got angle A, angle B, angle C, and we have the three sides, 4, 7, and 2.8. Now continue on and complete the other problems, making sure you're using your SOHCAHTOA. And it looks like you have plenty of work to the right of the problem over here. So make sure you write out what you're doing. And in case you make a mistake, we'll be able to see exactly what help you need. See you all tomorrow.